Hey, we have this big integral on the board. We have minus 12, the integral of minus 12 over 64x plus 78 minus 44 square root of 4x plus 3. Thought this was interesting because just that the denominator looks so hard to deal with at first because there's not an obvious u substitution, and we don't have, it's definitely not a polynomial that we can factor that I know of. I wasn't sure what to try first, but when you come to that case, usually the best thing to do is try a u substitution and try to simplify the radical. So what we'll do is we'll just set u equal to square root of 4x plus 3. And then what I'm going to want to do is we want to find a value for this x, right? Because this will simplify nice, but then we need to find what is x going to be. So let's square both sides here. We'll have u squared equals 4x plus 3. Then we can try to solve for x. So we'll have u squared minus 3 divide by 4, and we'll have x equals this. I just want to clean this up a little bit and write it as x equals u squared over 4 minus 3/4. Now that we have our x value, let's find our dx by just taking the derivative. And then we'll have here, using the power rule, this is going to work out to 1/2 u du. Now I think we have everything we need. We have our u value, our x value, and our dx value. So I'm going to do, let's rewrite the integral. I'm going to take the minus 12 out front, and then we're going to rewrite our dx first as 1/2 u du. Then, okay, so our x value, let's just we'll write it all out. So substituting in our x value, this is going to be u squared over 4 minus 3/4 plus 78 minus 44, and then we have, this is u, so this is just going to be a u here. Next, we just need to distribute this way. Well, when I do that, let's one step, let's take this half out as well. So half times minus 12, we're going to have minus 6 in front. U du, okay, so 64, then, sorry, onto the denominator. 64 times a fourth is going to be 16. So we'll have 16 u squared. Here it's going to be, again, 16, but times 3, so we're going to have a minus 48 plus 78 minus 44u. One more step, we can take this piece and rewrite this as 30. You may think we could just try another u substitution, like call it v, and do that because we have our u on top. It ends up, it's not really going to help us, so what I want to do is factor the denominator and try to use partial fractions. Let's just see how we can factor this. So I like to just write out my parentheses and try to see what works. So if we have 4u times 4u is 16u squared. Because this sign's positive and this sign's negative, we're going to need to multiply two negative numbers, so I can fill in a negative sign here. And then you'll notice, I think if we do 5 times 6, that's going to work because 5 times 4 is 20 and 6 times 4 is 24. So then we can rewrite this integral. Then for the next step, what I want to do is partial fraction decomposition on this integral. So we'll rewrite this, and we'll set up our form. We'll call our numerator of the first term a, and then our numerator of the second term b. And I'm just going to make sure we don't forget to include our 6 on both terms. So I'm going to write it like this. Then a good way to do this quickly, we can use the cover-up method, which means we'll look at our first term here and figure out, okay, what for this term, what do we need to plug in for u in order for it to be 0? And that's going to be 5/4, right? If you plug 5/4 in there, you get 0. So then if we do that, we can kind of cover up this, plug in 5/4 for u, plug in 5/4 here, and then for this term, the 4's are going to cancel. 5 minus 6 is -1. So for our a, we have minus 5/4. Next, we'll do the same thing for the second term. We want to know what is going to make this equal to 0. So that would be 6/4 because the 4's would cancel, but 6/4 is the same thing as 3/2. So we know if we put 3/2 in there, we can kind of cover it up. And then we just need to plug our 3/2 back in over here. So we'll have 3/2 in the numerator, and then 3/2 in here is going to be 3/2 times 4 is 2. no, is 6. 3 halves times 4 is 6, minus 5 is 1. So then we just have 3 halves over 1. So we can say our b value is 3 over 2. So now I've just rewritten this and I've plugged in the values we found for a and b. The only thing I changed was I distributed the minus 6 to both integrals and separated into 2 integrals. Next thing I'm going to do, let's just multiply. Let's bring this out, and so we'll create a new constant out front of each integral. So minus 6 times minus 4, minus 6 times minus 4 over 5 is 30 over 4, which is 15 halves. Then minus 6 times 3 halves is minus 9. So now we're ready to integrate. So the only thing we have to remember is because we have a coefficient on this term, we can't just take, it's not just going to be ln of 4u minus 5, it's going to be ln. We're going to have to bring the 4 in the denominator. So we're going to end up with, for this one, 15 over 8 ln absolute value 4u minus 5 minus 9. But again, same thing here. We're going to have a 4 in the denominator that we pull out. Ln absolute value 4u minus 6 plus c. And the only thing we're left to do is we just need to back substitute. We need to bring back our u here and our u here. So rewriting this, we're going to have 15 over 8 ln 4 square root 4x plus 3 minus 5. Don't forget your absolute value. Minus 9/4 ln 4 square root of 4x plus 3 minus 6 plus c. Got this problem for my quiz, integrals with roots. I'll leave a link in the description. Hope you check that out. Thanks for watching.